Welcome to Summarize Science, where we dive into the latest breakthroughs in technology and research. Today, we are looking at a fascinating study about a new kind of digital threat called autonomous LLM agent worms. As AI agents become more like personal assistants, they are being given the power to read files, send messages, and manage their own workspaces. However, researchers have discovered that these very features create a dangerous pathway for malicious software to spread autonomously. Unlike traditional computer viruses that exploit bugs in software code, these worms use natural language to trick AI models. The researchers found that in these AI systems, reading untrusted content can actually be more dangerous than having an attacker write to a file. This is because the AI treats the text it reads as a direct command for its decision-making process. They developed a systematic framework to see how these worms can survive and spread across different AI ecosystems. Figure 1 illustrates the three phases of their research: automated discovery, attack analysis, and the construction of a formal defense. Using a specialized tool they built called SSCGV, they scanned three major AI frameworks to find where these injections could happen. They discovered over 30 different carriers, or files, that an AI might read, which could be used to host a worm. The study also introduced a way to make these worm payloads summary resilient. This means the worm stays effective even if the AI tries to shorten, paraphrase, or compress the message during communication. One of the most concerning findings is that this allows for zero-click propagation. A worm can jump between 3 or more different agents without any human interaction required after the initial message. It can even hop across completely different AI platforms as long as the agents share a common chat channel. The researchers demonstrated that these worms could be used for malicious goals, like stealing sensitive data from an agent's workspace. They also showed how a low-privilege agent could trick a more powerful agent into performing high-risk actions through trust-based delegation. To combat this threat, they proposed a new defense framework called RTWA. The core idea is to block the temporal reentry of tainted information into the AI's reasoning context. This system marks any information that comes from an untrusted source as tainted. If the AI tries to read that tainted info back in before performing a high-risk action, the system automatically denies the request. In summary, this research proves that as we give AI more autonomy, we need entirely new ways to think about digital security. It shifts the focus from simply blocking writes to carefully monitoring and tainting what the AI reads. In the future, this work will help developers build much safer digital assistants that are immune to linguistic infections. Understanding these vulnerabilities now is the best way to ensure a secure AI-driven world later. Thanks for watching Summarize Science, and stay tuned for more deep dives into the world of discovery.